Hi everyone, I'm Jocelyn Barbosa, and in this session we are going to learn the difference between the classification and regression model, which are two of the important components in machine learning, particularly the supervised learning. But before we dive into the details of the difference between these two models, let's take a step back first and have a quick review on the three categories or types of machine learning. And so we have the supervised learning, unsupervised learning, and reinforcement learning. If we can recall our previous video, we define machine learning as the science of making computers learn or think and even act like human beings by feeding data and information without being explicitly programmed. It has actually three categories: the supervised learning, unsupervised learning, and the reinforcement learning. In supervised learning, machine learns under supervision or guidance, and if we can imagine a teacher in a classroom who guides students to learn something and says these are the data or the inputs and this is the output, how the output should look like. And in this case, the teacher is the training data. And as such, a student learns with the guidance or the supervision of a teacher. And just as a student learns through the teacher's supervision or guidance, a machine learns from the pre-labeled historical data. And due to the fact that the data instances used for learning, called the training data, are labeled with predefined classes, the machine or the method is called supervised learning. While in unsupervised learning, the machine is given training based on unlabeled data without any guidance. Imagine an adult, for example, like us, who can do routinary tasks without being supervised by somebody else. We can do things on our own, whether or not the output is good or not at all, and even find out reasons for not doing it well. So in other words, data is not labeled and there is no guide at all, and in this case, the machine has to figure out the data laid down and find some hidden patterns in order to deliver a particular output or information essential for coming up with very important decisions. This type of machine learning algorithm is used to draw inferences from datasets consisting of input without labeled responses, unlike the supervised learning. And the most common unsupervised learning method is the cluster analysis, which is used for exploratory data analysis to find hidden patterns or grouping in data. In reinforcement learning, there is a reinforcement learning when a machine or an agent interacts with its environment, performs actions, and learns by the trial and error method. For example, we imagine how a person adapts situations and how to live with all the challenges in life. A person is being lost in a place, perhaps ended up in a very isolated area where he is not familiar with and he doesn't even know where to find food, etc. But as time goes by, he learns to adapt things, even learn what to eat and what not to eat, and even adapt weather or the climate. In this case, trial and error principle or concept is being applied because, of course, he is new to the surroundings, and the only way for him to live is to experience and learn from that experience. For supervised learning, we have two categories. We have the classification and the regression. For classification, when the target or output variable is categorical, that is having two or more classes, for example, true, false, or yes or no, or binomial class 0 or 1, we make use of classification in this case. But with regression, it is nothing but a relationship between two or more variables where a change in one variable is associated with the change in another variable. So an example of a classification is when we are to determine whether the email is a spam or not. So the machine learns from the previous collection of pre-labeled emails and scans the content and finds out its categorical separation based on its attributes and characteristics in order to create a model so that once a new email is received, it can predict or classify either spam or not spam. So in scanning the contents, perhaps one of the attributes to look into is the header, wherein there is an attachment of the text, for example, claiming of prizes or even lottery, etc. For regression, we have an example, a use case example of a weather prediction, wherein if you look at the figure, say we have two variables, the temperature and the humidity. In this case, the temperature is dependent, or the temperature is the independent variable and the humidity is the dependent variable. For example, if by observation, as the temperature, the value increases, the humidity increases, and so we can say that two variables are correlated to each other. So when these data are fed to the regression model, it will understand the relation between these two variables, and after the machine is being learned and it can create a model, it can then predict the humidity based on the given temperature that is our new data. So that's how regression works. So if you look at the difference between classification and the regression, the classification actually talks about a task of predicting a discrete class label. That means that in a classification problem, data is classified into one or more classes. If we have two classes, that we call them as binomial classification or binary classification. And if it has more than two classes, we call them a multi-class classification or multinomial. And for example, as we have cited earlier, we can do a classification whether an email is a spam or not, and then whether the customer buy life insurance or not. That means yes or no, binomial classification. Or we can have a multinomial classification. For example, if we are to predict which party a person is going to vote for, given these three possible values. But for regression, a task of predicting a discrete continuous quantity. When we talk about continuous quantity, we talk about continuous variable, that is a variable that has infinite number of possibilities. So a regression problem requires the prediction of a quantity. We also have multiple input variables, and that is called multivariate regression problem. So for regression, we can cite an example, a use case wherein the independent variable is the house size. That means that the predicted price would depend on the value of the house size. If you can see here, there is a regression line that is telling us that there is a correlation between the house size and the predicted price. As the house size increases, there is a high likelihood that the price also increases. So another example is the stock price. During a period of time, the price of a stock might increase. And another regression problem is on the weather prediction, as we have mentioned earlier. So another application of the regression model is on the assessment of risk in financial services and insurance domain, wherein the linear regression model can actually help to analyze the risk. For example, the insurance company might conduct a linear regression algorithm, that is by plotting the number of claims for customers against its age, and that they might discover that the old customers tend to make more insurance claim, and such results might guide or give an aid to make some important decisions. And finally, looking into the predictive or the prediction value in this, both the classification and regression. For classification, the prediction value is categorical, and while in regression, the prediction value is continuous. That's a very important difference between these two things here under the supervised learning. So I think that's all for the difference between classification and regression, and I'll see you in the next video.